In this video, we are going to talk about the two standards in our unit comparing and ordering whole numbers and decimals. Now this starts with 5.2a, which is a supporting standard, but you are going to see why that's so important to lead to our readiness standard 5.2b. So let's talk about 5.2a first. 5.2a requires us to represent the value of the digit in decimals through the thousandths place using expanded notation and numerals. So that's a whole lot going on in just a supporting standard. So in 5th grade, we introduce for the first time the thousandths place. They've never heard of that before. They've gone to the hundredths place in 4th grade. In 5th grade, they go to the thousandths place. So for your understanding, in 5th grade, we work with place values from the billions all the way down to the thousandths. Those are the place values we work with. Now, that means that could be some really, really big numbers. So when we're working with these, we need a way to organize our work. And the work that we do when we are trying to compare and order is based on place value, which is why this standard is so important. So here we are writing numbers using expanded notation so we can compare the place values of each digit. Okay, that's why these two are tied together. So expanded notation. There are a couple of important things about expanded notation. The first one is the numbers can be written in two ways. I can write expanded notation with fractions or decimals, and I need to do that both ways. I need students to see that both ways. So let's look at an example of see what I mean. If I asked for the expanded notation of 62 and 106 thousandths. So we're going to make sure in this standard, this is the very beginning of the year, we are going to ensure that we are reading numbers correctly and students are reading numbers correctly, because that lays the foundation for our year and our expectations. We're not going to let students say 62.106. We aren't going to say point anything. We are going to read the number correctly. 62 and 106 thousandths. Notice I didn't say 62 and 106 thousandths. The only place you can read an and is where the decimal is. We tend to say and within numbers way more often than we should out of habit. So you're going to have to be very aware of how you're reading numbers and how kids are reading numbers so that they're reading them correctly. So back to this number, if I needed to represent this in expanded notation, it would look like, I'm going to do fractions first. 6 times 10 plus 2 times 1. Notice I'm giving the value of the place that number is in, plus, next time to 1/10. 1 times, I'm doing fractions, 1/10. That's the place value it's in. I don't have to put anything for this 0. It helps some students to have that structure to go ahead and put the 0 until they get comfortable to not put the 0. But it is not required, and it would not be wrong if I went right to the 6 times 1,000th, which is what we're going to do. If you have a student who needs to put every place value to help with the structure with a lot of numbers like this, that is fine. Please allow that and then help them move past that. So the next one I will do is the 6, and it is in the thousandths place. So this is one way to write expanded notation for 62 and 106 thousandths. The other way is to write that with decimals instead of fractions. So that would look like 1 times 1/10 and 6 times, I missed my 0, 1,000th. So notice this represents the exact same number. This is another way to write 1/10. This is another way to write 1,000th. So kids need to work with this both ways. This is going to lay the foundation for later when you are asking students to write things like 1/10 as a decimal, because they need to add it to a decimal number. So they have to know that I can write 1/10 as a fraction or a decimal. When we get to our unit later in 5-3K, where we are adding decimals, whole numbers, and fractions all together, add all positive rational numbers, kids need to understand that there's more than one way to write 6/10. I can write it as a fraction or I can write it as a decimal. So you're laying that foundation now that this is the same number. Okay, we use all of this information to help us when we are ready to start comparing and ordering numbers. So in 5th grade, we are going to compare and order 2 decimals to the thousandths and represent using greater than, less than, or equal. I'm going to tell you the same thing that we tell every grade level from 1st grade when we introduce the symbols. Please don't teach tricks. Please don't teach them that these are alligator mouths that eat the bigger number. Please teach them what the symbol means. We're working really hard on that in the primary grades, and we want to continue that all the way through. The problem we are seeing is students are getting into algebra classes and not being able to read these symbols. They think it's just an alligator mouth. Well, when you see something like X is greater than Y, you don't know what the alligator's doing because they're just 2 variables and you don't know their value. So if I don't know what this symbol means, I can't read that to you. So I need kids to know what the symbol means, know the name for the symbol. No tricks. It's critical for their success in future grades. So no tricks. Now we're comparing. These are our 2 verbs for this unit. We have to compare. That's using the symbols. And we have to order. So those are 2 different verbs. Comparing might look like, if I use this same number that I had earlier, 62 and 106 thousandths is greater than 62. So I'm comparing them with inequality symbols. When I'm asked to order them, then I'm asked to take 3 numbers, sometimes more than that, and put them in order. It can be greatest to least, or least to greatest. So I have to model both ways. This is typically done in a real world type of a problem. The types of problems that get them in trouble is when it's race times and you want to know who won. If I'm the winner of a race, my speed, or my time in this case, would be the smallest number because it means I ran the race the fastest. Students tend to mix that up because we equate winning with biggest. But if I'm running a race, the time that I completed the race needs to be the fastest time or the lowest time. So have lots of opportunities to talk about things like that. Like, what does it mean when I win a race? This would be a great opportunity to get your PE coach involved with timing kids when they're running something, or timing them doing a certain number of sit-ups or jumping jacks or pull-ups or any kind of things like that, where they can time them and then put those times in order from the winner, the lowest, to the greatest time, and understand that the winner is the lowest time, and they go in order from least to greatest when you're trying to show the winning time. Important things about this. Kids have to understand that they need to use a strategy to organize their work. If I was going to compare, let's think of these 3 numbers. Or sorry, not compare, order them. I need some structure to that. Otherwise, there's just a lot of numbers here. So I want the kids to line the numbers up by their place value. So if I start by lining them up, the next thing I want them to do is add in a 0 at the end of any number that doesn't have the same number of digits as the rest. So here I would want them to add a 0. That's called annexing a 0. This will generate some conversation in your classroom because students don't always believe you that the number value didn't change when you added a 0 to the end. This is when you get out place value blocks and show them that 5/10ths is equal to 50/100ths, so they understand. And you can do that with smaller numbers, so you don't have to have 50/100ths out, but you could do that with 1/10 is equal to 10/100ths, so that they understand you didn't change the value, you just put a 0 so that you could easily compare. So then in our process, the next thing we would want to do is compare by place value, starting with the largest place value. These are all zeros, so they're not helping me out. Let's also say over here, we're going to put them in order from least to greatest. These are all zeros, so that doesn't help. Here I have a 5, a 0, and a 5. If I'm going from least to greatest, I need the least one of those. So least would be 5/100ths, so I've used that one. Then I would go to the next place value. I have a 1 and a 0. See why it's important now that I put this 0 here so I have something to compare. So what's the next lowest number? The least is the 0. So the next one, and then the last one, I've used them all, and they are in order from lowest to greatest. We want to practice that least to greatest and greatest to least and make sure we're varying those situations. They're not always going to have a 0 in the ones place. These can be large numbers. If you look back at some of the STAR released, you can see that they've tested this with weights of different animals, weights of suitcases, speeds, distances. So there's all kinds of real-world application for this to help students understand. They can typically apply this very easily to money, and it's a great way to introduce it because they're understanding what's the least amount of money and the greatest amount of money. That's very applicable to them, and they like to figure that out. So lots of real-world applications for both of these standards, lots of practice with writing in expanded notation in the fractional form and decimal form. And remember that anything they've learned prior grades is fair game for this. So we're not always going to do the thousandths place. We're going to practice expanded notation with any numbers from billions down to the thousandths place.